Okay, this is section 6.1, and in this video we're going to talk about how to graph a simple exponential growth or exponential decay function. And so what I have here is just an example of what we call an exponential growth function. And the key thing is that the x variable, which could be something else, is always part of the exponent. Okay, and so when you have an exponential function, it could be exponential growth, or exponential decay. And so before you start graphing, it's good to kind of recognize what type of function you have, just so you have an idea of what the shape of the graph is going to be. And the key thing is what we call b. And so if we go through the parts here, a, whatever value that is always the original amount. And in the next video we'll go through some real world problems where a will change based on the problem. On the graphing that we're going to do here, a is always going to be 1, but that's not always the case, so you just have to be familiar with that. But then b, which is the base that has the exponent, that's going to be either your growth or decay factor. And so we have an exponential growth function if b is greater than 1. It's going to be exponential decay if b is between 0 and 1. Okay, we're not going to deal with when b is negative. Sometimes a will be negative, but that's not really something we're going to talk a lot about right now. But b will never be negative, and it'll never equal 1. If b was 1, then no matter what exponent you took 1 to, you would always still get 1. So it's always going to be either greater than 1, which will be growth, or it'll be between 0 and 1, which will be decay. Alright, so an example of a growth function would just be y equals 3 to the power of x. Okay, and so I think probably most of you have an idea of what an exponential growth function would look like. We use that as we talk about things a lot, how something grows exponentially, and that just means that the growth is not constant, but it continues to grow at a faster rate the higher that you go. Well, to start with this function here, what we're going to do is we're going to create a little XY chart. And as you go through these problems, you'll want to create a little XY chart just to get some points. We're not going to get a lot of points on the graph because you should have an idea of what the graph looks like. So we're just getting a few points just to get some accuracy. But if I chose 0 as x, 3 to the power of 0 is 1. If I chose 1 as x, 3 to the power of 1 is 3. If I choose 2, 3 to the power of 2 is 9. And of course from there you can kind of see it's going to get the y values will get higher pretty quickly. So for example, if you put 3 in, then you'd have 27 and so forth, which is going to be too hard to graph. So if I had the points, I have 0, 1, and then 1, 3, and then 2, 9, 4, 5, 6, 7. Okay, so it looks something like this. And so the full graph is going to look something like that right there. Okay. Now a couple things. We didn't put in any negative values, but we could. If we put in -1, 3 to the power of -1 would be 1/3. If we put in -2, 3 to the power of -2 would be 1/9. And so those get to be very small decimals. Okay. This graph will never touch the x-axis. Okay, so it'll never actually, the y value will never actually equal 0. It'll always be greater than 0. And theoretically the graph will expand. So the domain for this graph is all real numbers. The range is y is greater than 0. Okay. Okay, if you take a look at exponential decay, in this case we would have something where b is less than 1, but not less than 0. So it's a fraction, but you have to be careful because it has to be a fraction where it's less than 1. So for example, if b was 5/3, that would still be growth, but we'll go with y equals 2/3 x. So again, if we create just a couple of values in our xy chart, if we put 0 in for x, and I'm sorry I didn't write that correctly, that should be to the power of x. Okay, so if I put 0 in for x, 2/3 to the power of 0, of course, is still 1. When you put 1 in for x, 2/3 to the power of 1 is 2/3. If you put 2 in for x, that would be 4/9. Okay, and you see these values are going to get pretty low. If you put in negative values, for example, if I put in -1, 2/3 to the power of -1, well, remember what a negative exponent means is we're going to do the reciprocal, so that would be 3/2, or 1.5. If you put in -2, that would be 9/4. So, still start with 0, 1. We have 1 2/3, 2 4/9, -1, it was about 1.5, and then -2, 9/4 is about 2 1/4. Okay, so at this point, the graph is going to look like this. Okay, again, same thing with the growth. It's never going to touch the y-axis. And it's going to approach starting from -infinity and coming down and then approaching 0. Okay, the domain is still all real numbers. You can put anything in for x and get an answer for y, but the range is y is also greater than 0. Okay, and that's really going to cover the graphing. We're not going to do a lot of graphing, but you need to have an idea of what the graph should look like. Now, just as kind of as a side note, if you think about the transformations that we've done other times, we could transform a graph like this, where it would look like x minus h plus k. Okay, so I'm just going to kind of do something over here in the corner. So if you had like y equals 3 to the power of x minus 2 plus 1. Okay, well, that's the same graph that we have over here in number 1, only in this case we're moving everything over to the left 2 and up 1. So for example, if we started here, the first point was 0, 1. Well, when we transform it, instead of 0, 1, we move it to the left 2 and then up 1, which would be the point -2. I'm sorry, I didn't do that right. To the right 2 and then up 1. So it would be to the point 2, 1. Okay, cross that out. And then the next point was 1, 3. And so if we started with 1, 3, then we move that to the right 2 and then up 1. And then 2, 9, we move that to the right 2 and then up 1, so that would be 4, 10. Okay? And so the graph in that case will look something like this. Okay? And like I said, in this section we're not going to deal a whole lot with these. I just want to show that to you because you'll see that sometimes. But for the most part, it's just you need to be able to graph these two first basic functions.